This is a car with a conventional suspension, and this is the car with the Bose suspension. This system was presented by the company back in 2005. It was an electromagnetic suspension that kept the car completely stable. And street obstacles were not a problem either. It can even avoid a tree branch across the road by jumping over it. It looks like witchcraft, but it is really just technology. And here is something curious. Bose, the company that made the system, is an audio equipment company. But why, after more than 2 decades, are we still using regular suspensions instead of this electromagnetic one? And is there still hope that your car in the future will have this amazing suspension system? In 1980, Amar Bose, founder of the Bose Audio Equipment Company, formed a group of MIT engineers and others from his company to develop the ideal suspension. This change of focus from other company projects happened because, according to him, in 1957 he had bought a Pontiac Model 58 with the first air suspensions, and later a Citroën 1967 with a hydraulic suspension that was always leaking. He became fascinated by the function of the suspension, which should control the wheels and deliver comfort to the driver. So he came up with the idea of a new system that would be much better than existing suspensions. According to him, the electromagnetic suspension project for cars, which would come to be known as Project Sound, would revolutionize the automotive industry. The idea was to invent a system that anticipated road bumps. It would be like riding on a magic carpet. In 2004, after 24 years of research, the system was installed in a 1994 Lexus LS 400, a luxury car of the time with one of the best suspension systems. In 2005, the company presented the prototype, as we can see in this video, where they compare it with another original Lexus and with a Porsche. The system eliminates practically 100% of the oscillations in the car body. It's so good it almost looks fake, but it is real. In the test, they took 2 identical 1994 Lexus models. The dark one was left original, and the white one had the Bose electromagnetic suspension system installed. The Bose active suspension system controls each wheel individually, removing the body oscillations. A standard suspension system uses springs, shock absorbers, and control arms to soften road imperfections and car oscillations. These are passive systems that react when impacts occur. In the Bose active system, the suspension becomes an actuator. The actuators in the suspension are linear electric motors operating in 2 directions of the axis, in this case, up and down. On the axis that moves up and down, there are permanent magnets. On the outer part, the stator, there are electric coils. By applying an electric current to the coil conductors, an electromagnetic field is created that attracts or repels the magnets, making the axis move up or down. A linear motor is like unrolling the stator of a rotary motor. This way, it produces force in a straight line instead of rotationally. In this system, the linear motors replace the traditional springs and shock absorbers. But there are still 2 small traditional shock absorbers to dampen high-frequency vibrations. Accelerometers on each wheel and on the chassis, along with other sensors, detect the car's acceleration, wheel movements, and road changes, sending this data to a controller. This controller runs an algorithm that identifies what is happening and determines the current signal that should be sent to the actuators in each suspension. The actuators push or pull the wheels individually according to terrain variations, keeping them always in contact with the ground. They also prevent body rolling curves during acceleration or deceleration. All this happens in a few milliseconds, keeping the car almost 100% stable. If the suspension movement is up to 20 centimeters, the car occupants do not feel any motion. 20 centimeters is quite a lot. The entire weight of the vehicle is supported by the magnetic force of the linear motors. At higher speeds, the system even lowered the car to reduce drag and improve stability. This system was also regenerative. That is, when the wheel goes up over a bump on the street, the wheel acts against the suspension. The motor then absorbs part of that energy and stores it in the vehicle's battery. The electric motor only spends energy when the wheel goes down the bump. With this, the system ended up consuming only 1/3 of the power of a car air conditioner. According to project engineer Neil Lackritz, at the time, there were no motors with the necessary combination of strength and efficiency, nor adequate amplifiers, so they had to develop their own version. But an even greater challenge was designing the control system, both the algorithm and the controller. It had to read sensor signals and make precise real-time decisions. As the car moved at higher speeds, the controller had to process and act faster and faster, requiring great processing capacity. Only with the arrival of Intel's Pentium CPUs in the 1990s did the system reach an acceptable processing speed. The controller, at the time of this video demonstration, used a Pentium 3 of 750 MHz. The control developed to drive the linear motors was very similar to the loudspeaker control system developed by the company. That is, the company was still applying its expertise in this project. Although the project was a technical success and worked incredibly well, it was very expensive and also very heavy to be integrated into a normal car without drastically redesigning it. This, unfortunately, made it a commercial failure. The goal of the Bose engineers at the time was to keep the system weight at most double the weight of a normal suspension. That meant, according to them, each wheel's suspension should add at most 22.5 kilograms. This gave a total increase of 90 kilograms. It may not seem like much, but it significantly impacts fuel consumption. Considering a luxury car, that meant about 5% more total car weight. In a popular car, it could reach 10%. At the time, companies like Jaguar, Mercedes, Honda, and Ferrari were very interested in the system, but when they saw the numbers, they left the project at the altar, and the global financial crisis of 2008 put an end to the project once and for all. They managed to recover part of the $100 million invested during 24 years of research by opening a company called Bose Ride, which manufactured active suspension for truck seats. Until, in 2017, Bose sold the technology to ClearMotion. To make the system marketable, ClearMotion abandoned the idea of the linear electric motor and applied Bose's control and sensing software to its own valve-based active suspension system. Instead of being electromagnetic suspension, it is electro-hydraulic. Each of the 4 suspensions has a digital controller that detects road disturbances and returns commands to the controllers, which send signals to the electric motors with the exact hydraulic pressure to be applied to the shock absorbers. All this in less than 5 milliseconds. They called the system a digital chassis. This system also sends and receives vehicle data from the cloud to create high-definition road surface maps. This crowdsourced data allows vehicles equipped with ClearMotion suspension to proactively adjust to road conditions, enhancing comfort and safety by anticipating and counteracting bumps and other surface irregularities before the car encounters them. The system is also regenerative. When the wheel acts on the suspension, the shock absorber fluid is directed through the valve, driving the pump and motor, which starts generating energy, creating controlled damping. This system promises to be much lighter and cheaper than the original Bose one, and also does not require major vehicle adaptations, although apparently it does not respond as fast as the one with electric motors. According to them, at least 6 automakers were interested in the system. The company's plans were to implement the system in 2019 in some test vehicles and begin mass production in 2020. But the target market it's really aiming at is autonomous cars. Since people will be free during the ride, they will want to do activities such as using their phone, laptop, or drinking coffee. Imagine how it would be with the car totally stable. Nowadays, there are also other automakers investing in active suspension systems, such as Audi with the A8, which maps the road with cameras and anticipates bumps and surface imperfections. ClearMotion also plans to use a camera system, which will also make use of the cloud and share the roadmap with other vehicles. There is also the German company Vibroacoustic, with a system similar to ClearMotion's already implemented in the Porsche Cayenne. Mercedes also has its active airmatic system, with air suspension and road mapping cameras. And to think that Bose already had a working prototype back in 2005, which could have been improved but ended up being left aside all these years due to financial issues. In the meantime, other companies ended up developing their own systems, but none of these new models can jump obstacles. It is curious how a technological breakthrough can come from such an unexpected area. In this case, the most advanced suspension system of its time came from an audio equipment company.
Automotive engineering can reach incredible levels, from these types of suspensions that make a car glide like a magic carpet, to limousines that look fairly normal from the outside, but are built with various secret protection systems to keep the most powerful person on Earth safe. Click the video on your screen to know about these amazing hidden systems.